The symptoms have progressed where my left hand and arm are increasingly weaker, and my voice is starting to go, and some difficulty swallowing, that sort of thing.
The disease really is characterized by, for the most part, normal mental function and normal sensation. So patients gradually get weaker over time. It's not, unlike stroke, it's not a disease that occurs overnight, but rather over a long duration.
What happens is the signaling mechanism for the motor neuron, the chemistry that goes haywire, and then the motor neuron, which is the nerve that drives the muscle, starts kind of shorting out, and then that nerve dies and the muscle goes along with it.
You could go home pretty overwhelmed by kind of the gravity of it, that every patient you see is dying, and so that makes it a challenge to kind of be able to take a step back and being able to treat the patient with respect and with enthusiasm, but at the same time realizing that it's a tough road for those patients.
I think from both scientific point of view and therapeutic point of view, stem cells is really exciting field to be in at this moment, because there are major breakthroughs happening almost every day in this field. It's very competitive, but it's also very fast moving.
Doctors are going full bore as fast as they can on this research, and now I think with the funding there and taking away the regulatory hurdles which existed for the last 8 years, I'm very optimistic about that.
For ALS therapy, using stem cell technologies is twofold. One is to use stem cells to replace the body's own sick or dying cells.
Cell replacement therapy. So for example, you are losing motor neurons in ALS, so we'll try to replace them.
And the strategy then is to really transplant those back into the spinal cord. So we need to identify what cell types are sick, replace those cells with our stem cell types, whether they be astrocytes or nerve cells, and then hope for neuroprotection in that setting. And the second strategy is really using stem cells to discover really in the dish what causes the disease.
Stem cells can give rise to cell types which are affected in human patient. So we can use them to study what's wrong in humans, why they get this disease. And we can also use these cells to screen for novel therapies, to test them in the dish. And then eventually we can go back to patient and in clinical trials to test whether these therapies we identified are effective or not.
Hung Joon really brings to the table all the understanding about how to push stem cells into different mature cell types, how to push them into astrocytes or how to push them into motor neurons. And then with our most recent collaborative project, how to turn skin cells back into cells from the brain, something we call neural stem cells.
You actually can turn the skin cells into cells with the stem cell properties. People call them induced pluripotent stem cells or iPS cells. So these cells actually has the potential almost like embryonic stem cells. So the potential of these cells in medicine, of course, is enormous.
I think the stem cell technologies offer so much with regard to therapy and with regard to understanding disease that I think it's a very viable approach, and we've only really scratched the surface as far as those opportunities.
They're getting close now. It will be for others to enjoy this benefit, so it's great.